In our last unit, we used the word root to represent the solution of an equation. Here, we're going to use root to represent an operation on a number. So we talked about exponents. So if I gave you something like x to the third is equal to 8, this really says what number, if you multiply it by itself 3 times, I gotta spell this right, multiply it by itself 3 times is 8. Now remember, it has to be the same number, so if you think about multiplying a number by itself 3 times, you can do this and figure out really quickly that x must be 2. Well, another way of looking at this problem is looking at what the opposite of cubing is. And the opposite of cubing is something called cube rooting. Cube root function on your graphing calculator can be found under the math function. So if you actually type in cube root and then 8, the calculator will tell you that it's 2. The reason it's 2 is because 2 times 2 times 2 is 8. So now, let's think about something very simple, like x squared is equal to 25. You know x is 5, but the reason x is 5 is because x must be the square root of 25. Then if I think about x cubed equals 125, the answer is also 5 because x must equal the cubed root of 125, which again is something you can do in your calculator. X to the fourth is equal to 625. You can find out what x is by taking the fourth root of 625. The fourth root in your calculator is a little bit different. You have to first type in 4 on the home screen, and then go to Math, number 5, which says x root, and then type in 625 and enter, and it will tell you the answer is 5. However, I'm going to say the answer here is actually plus or minus 5. The reason that it's plus or minus 5 is because not only is 5 times 5 25, but so is negative 5 times negative 5, because 2 negatives make a positive. The cubed root of 25, however, is just 5. Because if you multiply 5 3 times, you get a positive. But what happens if you multiply 3 negatives together? If you multiply 3 negatives, you get a negative. And then the fourth root of 625, again, is also plus or minus 5. So the pattern that's emerging here is that when you have an even root, the answer is going to be plus or minus the number, because an even number of positives when you multiply them is a positive, an even number of negatives when you multiply them is a positive. However, if you have an odd root, your answer is either positive or negative, depending on the sign of the radicand. What's the radicand? Well, in a radical form, this is called the radical symbol. Please do not call it the square root symbol, because it is only a square root if the root index is 2. The number under the radical is called the radicand. Now let's go and actually find some radicals. What are the real cube roots of 0.008, otherwise known as 8 thousandths, negative 1,000, and 1 over 27? Now, cube root means to do this. The way that they show you in the book, I have noticed that students are getting confused and writing down the wrong answer. If you simply do this in your calculator, the calculator is going to spit out 0.2. But another way of doing this problem is to rewrite 0.008, which is 8/1000ths, which reduces to 1 over 125. Well, all you have to do is take the cube root of the numerator and the cube root of the denominator. The cube root of 1 is 1, and the cube root of 125, or what number, if you multiply it by itself 3 times, is 125, is 5. 1/5 is also 0.2. The cubed root of -1000, because it's an odd root index, we can take the cube root of -1000. I'm going to tell you the answer is going to be negative. Well, what number, if you multiply it 3 times in a row, gives you 1000? Well, it's 10, so the answer must be -10. And the cube root of 1 over 27, I can take the cube root of 1, I can take the cube root of 27, and I get 1 over 3. But again, you could just plug it into your calculator and get the right answer. Now let's find the real fourth roots of 1, -0.0001, and 16 over 81. Since we're finding fourth roots, we can only find the fourth root of something that's positive. We can't find even roots of something that's negative, so this one is no solution. The fourth root of 1 is 1. That's an easy one. And then the fourth root of 16 over 81, you can do this. What number, when you multiply it by itself 4 times, gives you 16? It's 2. And the number that when you multiply it 4 times gives you 81 is 3. Or if you plug it into your calculator verbatim, it'll spit out the right answer. Now the next question might be, why did I not write plus or minus in this case? The only time you use plus or minus is when you're solving an equation. So if I give you x to the fourth is equal to 1, then you're going to tell me the answer is plus or minus 1. But if I just ask you to find the fourth root of 1, and it's not an equation, it's an expression that's being simplified, the answer is just 1. So be careful. Plus or minus is only used in the cases where you're actually solving an equation. It is not used when you are simplifying an expression. In this section, we are only going to deal with real roots. We've talked about imaginary numbers, which is what happens when there's a negative under an even root index. But in this case, we're only going to worry about real numbers. So if you cannot take the radical of a negative, because the root index is even, instead of using I, you're just going to say no solution. Now remember that when the root index is odd, like in part A, you can take the radical of a negative. So the number that when you multiply it 3 times gives you -8 is -2, or the graphing calculator or regular calculator will give you the answer. For 0.04, 0.04 is the same as 4/100ths, which is the same as 1 over 25. So this is really asking us to find the square root of 1 over 25. So the square root of 1 is 1, and the square root of 25 is 5. So it must be 1/5 or 0.2. The fourth root of -1. Wait a second, that's an even root, and it's a negative number underneath. It has no solution, because you can't take an even root of a negative. But D is different. And the reason D is different is because of the order of operations. The order of operations ask us to square before we do anything else. Well, -2 when you square it is a +4, and the square root of 4 is 2. So this is a special case where you actually can take the radical of a negative, but only if that negative number is being raised to a power first, such that it gets rid of the negative. Also, if you put that problem into your calculator and hit enter, it will spit out the right answer. Now we're going to talk about simplifying radicals that have variables underneath. Again, My opinion is that the way the book shows it does not necessarily make sense to students, at least not at this juncture. So I'm going to show you a different method from the way that the textbook does it. So I want to find the square root of 16x to the 8th. Well, I said earlier you could separate the radical over things like in a fraction. Well, it works this way for multiplication too. I can separate the square root sign over the 16 and the x to the 8th. Well, now you know the square root of 16 is 4. And some of you might figure out that the variable with an exponent that you multiply by itself to get x to the 8th is x to the 4th. So the answer must be 4x to the 4th. But another way of doing it, if you're not sure how to do it, is to use prime factorization. Factor tree, break everything down. So 16 is 4 2's, and then there are 8 x's. A square root says, how many groups of 2 of the same thing can you put together? So I can put together 2 groups of 2's, and I can put together 4 groups of x's. Well, there's my 4x to the 4th. Now let's find the cube root of a to the 6th, b to the 9th. Now again, some of you may be able to look at that and figure out real quickly that you have to multiply a to the 3rd, a squared 3 times in order to get a to the 6th. And then you would have to multiply b to the 3rd 3 times to get b to the 9th. But if you don't see that, again, you can expand this out, writing out 6 a's and 9 b's. A cube root says how many groups of 3 of the same item can you put together? Well, I can put 2 groups of 3a's together, and I can put 3 groups of b's together, and that's where my a squared b cubed comes from. And another thing you might have noticed at this point in time is if you take the exponent and you divide it by the root index, you'll get the exponent. 6 divided by 3 is 2. 9 divided by 3 is 3. That's a shortcut. This is the skill on how to do it very quickly. This is the concept. Now let's do the 4th root of x to the 8th, y to the 12th. Well, now we just figured out there's a shortcut for doing it. You can break it up into groups, oops, that's not a 12, by expanding both of these variables, or at this point in time you can tell me that 8 divided by 4 is 2, and 12 divided by 4 is 3, so it must be x squared y to the 3rd. Some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is a equals 10 times the square root of r, where a is the adjusted score. That means that's the score after the teacher determines they want to curve the test. And r is the raw score. The raw score is the original score that you get. If the raw scores on one test range from 36 to 90, what is the range of the adjusted scores? Well, all I have to do is plug in 36 for R, and then plug in 90 for R. So if a student gets a 36% on the test, the teacher is going to change it to a 60%. That's going to be the adjusted score. If a student gets a 90, the square root of 90 is not an integer, it's approximately 9.487. So this would be 94.87, and the teacher would probably round that to approximately equal to 95. So a student who got a 90 might actually get a 95. Notice that the lower the percentage, the bigger the just after the adjustment.